Hello everyone. So in today's video we're going to solve question number 11.3 from the chapter Alcohols, Phenols and Ether. So this particular question is divided into two parts. The first part says draw the structure of all isomeric alcohols of molecular formula C5H12O and give their IUPAC names. And the second question reads, classify the isomers of alcohols in question 11.3 first part as primary, secondary and tertiary alcohol. So what we're going to do is, as per the first question, we are going to draw the isomeric alcohols of this particular formula given to us. So here we are given with C5H12O11 or C5H12O, and we're going to name them individually, the IUPAC names. Apart from that, we are going to classify whatever names you wrote in question number 1. We have to classify those alcohols as primary, secondary and tertiary alcohols. Alright, so here the question given to us is C5H12O. So basically there is no restriction. You just have to maintain this, but ensure that all your products that you're forming are alcohols. Okay, so first thing, our open chain structure we can draw, which is the simplest one. So I'll just draw here CH3, CH2, 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 another CH2 and OH. So here I have is a pentanol structure. Alright, so the name for this compound is going to be pentanol. Alright, because I have a 5-carbon chain. Now, as per the molecular formula given to us, when we count the number of atoms, I have 5 carbons, then 22 hydrogens I need to get. So that's 3 plus 2, 5 plus 2, 7, 7 plus 2, here 7 plus 2, 9, 9 plus 2, 11, 12. Alright, I just made a mistake here. This is not 22, but that is 12. Alright, now, so here I have pentanol. Now the next thing is, what I'm going to do is, I'm just going to replace, I need to form an isomeric structure. They haven't told which isomer you need to form. So what I'll do is, instead of keeping OH in the first position, I'll just shift it to the second position. So here I have CH3, CH2, CH2, CH. Here I'll put an OH and then I'll put a CH3. Now over here, when I try to name this, I'm going to start from here 1, 2, 3, 4 and 5. Same structure, all that I've done is push the OH to the second position. So the name here can now be pentan-2-ol. I can also get another isomer by pushing this to the third position. So I'll draw that structure also. So I'll put here CH3, CH2, CH, OH, CH2 and the CH3. So here I can get pentan-3-ol. So I got 3 straight chains in which the OH group is at different positions. Now this is by maintaining the parent hydrocarbon as a 5-carbon chain. Now we know we can shift even a CH3 from there and get an isomer out of it, which means I'm going to maintain my parent hydrocarbon as 4-carbon chain here. That can also be another isomer. So I'll get CH3, CH2. One of the carbons I'm going to shift on position number 2 and I'm going to draw this. So what happens here, one of the terminal carbons I push to another position and I have an OH over here. Alright, now that is also going to be one of the isomer, because if you count and see, 1, 2, 3, 4, 5, 5 carbons are there. 3 groups where 3 hydrogens are there, that makes it 9, 10, 11 on this carbon and 12 on the OH. So I have all atoms intact, but this is another isomer where the parent hydrocarbon is a butane chain. So I'm going to number from here 1, 2, 3 and 4. When I try to name them, it's going to be 2-methyl butane-2-ol. Okay, so this is going to be another hydrocarbon. Alright, now, okay, another isomer is where I can push this OH to the first carbon and still have one more isomer. So that is CH3, CH2, CH, CH3, CH2 and OH. So what I've done from the previous structure itself, I pushed the OH to the terminal carbon. Alright, so here when I get the structure, when I name them, this is also going to be another type. So here I will get 2-methyl butanol. Alright, now another thing is I can still push this particular methyl group to another position. Alright, so I can push the methyl group to say the third position over here. In that case, when I draw the structure, I'll push this over here to the third position. CH2, CH2, OH. This is still 5 carbon chain. 1, 2, 3, 4 and 5. 3, 6, 7, 8, 9, 10, 11, 12. It still contains C5H12O itself. So here when I try to write the structure, this is going to give me, when I try to name them, this will give me 3-methyl butanol. Alright, another one more structure that I can get is by maintaining the CH3 over here and keeping the OH on this second carbon in the this particular answer. So let's try and do that. So I have a CH3. I'm just retaining that there and OH here and a CH3. Alright, so 3, 6, 9, 10, 11 and 12. Everything is maintained. So here when I write this name of the structure in this, I'm going to start from this side. 1, 2, 3 and 4. So I can write 3-methyl butane 2 all. Okay. So here I have done 2-methyl, I have also done 3-methyl. Further I cannot do anything. So with the 4 carbon chain, everything is done. Now another thing is, from the 5-membered chain itself, I can still get a 3 carbon chain. How? When I get a 3 carbon, this is my 3 carbon, I can push the CH3 over here and I can put the CH3 here. And I can have OH over here. Now when I count the number of carbon and hydrogens, carbon count is 5. That's correct. What about hydrogen? 3, 3, 3, 9, 10, 11. Now, 12 are there. Now here, this is another isomer of the 5 carbon, C5H12O. Now when I try to name this particular molecule, this will become 2,2 dimethyl 2,2 dimethyl propanol. Okay, so this is going to be the last one where I have a 3 carbon chain. More than this, I cannot do any more molecules. Alright, so these are the entire isomer. So totally I have 6, 7, 8 isomers of this particular molecule where I have C5H12O. Now that solves the first question that says draw the isomeric structures and give the IUPAC naming. Both are done. Now classify the isomers in this particular question as primary, secondary and tertiary alcohol. You need to classify them. Okay, so I'll use a different color ink now. Alright, now first one is you need to only observe that carbon that is bonded to the OH group. Alright, so in the first one, the carbon that is bonded to OH group, please remember, when you have carbon that is bonded to an OH group with 2 hydrogens, alright, this one is going to be a primary alcohol. When an OH group is bonded to a carbon that has 1 hydrogen, then that's going to be a secondary alcohol. And another one which is bonded to no hydrogens, they are tertiary alcohol. Now let's keep this in mind and then do it. Carbon is bonded to OH. This carbon has 2 hydrogens. Which one is it classified as? This is going to be a primary alcohol. Next one. Carbon is bonded to an OH. This particular carbon here has only 1 hydrogen, so it is a secondary alcohol. Then, in the third one, carbon is bonded to an OH with only 1 hydrogen. This is also a secondary alcohol. Next one. Carbon is bonded to an OH which contains no hydrogens. So this is a tertiary alcohol. Then carbon is bonded to an OH group which has 2 hydrogens. So this is secondary again. Then carbon is bonded to OH which has 2 hydrogens. This is again, this is primary. Sorry. Told it by mistake. This one is, both of these are primary. Alright. This is primary and this is also primary. Now the next one, OH is bonded to a carbon with only 1 hydrogen, which is secondary. Then OH is bonded to a carbon with 2 hydrogens. This is primary. So this way, you have to just follow the basic concept in order to identify, the primary, secondary and tertiary. Once you get a hang of how to answer that, then it's easy for you to, answer these kind of questions. Alright.